these transformations are very similar to what we've done in the past. So if you see a plus or minus grouped with your x, that's going to be a horizontal shift. If you see it kind of after the x, that is an up and down shift, vertical shift. If you see it in front, that would show you a stretch or compression, and if it was negative, it would show you a reflection. So let's get after it with a couple of these here. So sketch the graphs in 1 and 2 using a table, and then use them to graph the ones below it with just those transformations. So if we're just doing y equals 2 to the second, or 2 to the x power, now if we were doing 2 to the negative first power, that would be 1 over 2, which is just 1/2. So our coordinate would be -1 and 0.5, or -1 and 1/2. If we put in 0 for the exponent, 2 to the 0 power is just 1. So we're at 0, 1. And then if we put in 1, 2 to the first power is just 2. So this would be our, that was kind of a garbage left line there. But it will swoop and the asymptote will be at 0. So let's see some of the other equations we have. So y equals 2 to the x plus 3, it's not grouped with the x, so that would be a vertical shift. So it's going to take that exact same graph and shift it up 3 places. So this was at 1, so we'll go up to 4. Oh goodness. This was at 0.5, so now it'll be at 3.5. And this one was at 2, now it will be at 5. So the green graph shows that translated up 3 units. And again, the asymptote was at 0, now it's up at 3 because everything is shifted up 3. If you look at our second equation here, y equals 2 to the x minus 2. It's grouped in with the x on the exponent, so that would be a right or left shift. If it's minus 2, we're actually going to shift it to the right 2 places. So looking at our original red line, we're going to take all those points and just shift them to the right 2. And that, the asymptote didn't change at all because there was no vertical shift. And then if you look at number 7, it's 3 times 2 to the x. So we would take all these x values and multiply them by 3. So 0.5 times 3 is 1.5. So we'll have -1, 1.5. 1 times 3 is 3. And 2 times 3 would be 6. So this would be a stretch. But still has an asymptote at 0. Now let's try a logarithmic example, and it's got the same transformations, but for logarithmic examples, usually you'll see like a sideways graph more so because you're going to be using more of these x numbers and there's not as much change vertically. So if we put in 1/10 for x, think of log of 1/10. Well, that's saying 10 to the what power gives you 1 over 10, and that would be -1. So we'd have a coordinate at 1/10 and -1. So that would be down here-ish. Now again, my 1/10 isn't perfect. If we sub in 1 there, log of 1. 10 to the what power gives you 1. That's 0. So we go to the coordinate 1, 0. And then if we try 10 to put in for x, 10 to the first power gives you 10. So we'd have 10, 1. So here's what our log function would look like. And this one has a vertical asymptote at at x equals 0. That would be your vertical asymptote there. But left and right, it's all real numbers. Now here we have log of x minus 4. It's not grouped with the x, so that would just shift everything down 4 places. So if we go down 4, 1, 2, 3, 4, about there. 1, 2, 3, 4 is there-ish. And then 1, 2, 3, 4 would be there. So this one shows our log of x minus 4. Now this one, the second one, x plus 2, it's grouped with the x. So that becomes your right and left shift. So this would shift the original to the left 2 places. So our original is this black line. We're just going to take every point and move it to the left 2. Now this would have a different asymptote. This asymptote would be at x equals negative 2. And then if you look at this last one, negative log x, we'll just take our original black line and flip it. It would reflect it over the x-axis. So this one's right on the x-axis. This one is 1 away, so this would come up here. And then the one at 10 over here would come down to the other side. So it'd still have your vertical asymptote at x equals 0. All right. Describe the transformations. ln x minus 2 plus 5. Well, the plus 5 at the end would shift it up 5 units. When it's grouped with the x, that's a horizontal translation. So this would shift 2 units to the right. All right, let's check out this one. 1/3, okay, it's in front, so that would be a stretcher compression. Now, since it's between 0 and 1, it's compressed by a factor of 1/3. Let's see if I can scoot down. Here we go. Compressed by a factor of 1/3. The plus 8 grouped with the exponent there, grouped with the x, that's your right and left shift. So this would shift left 8 units. And this last one, woo, this has got a lot of them. So I see the 3 in front. That would be your stretcher compression. So this would be stretched by a factor of 3. There's just one other transformation. The minus 4 at the end would be shifted down 4 units. Sweet, that wasn't too bad. Now this one's going to be a little wild. We're going to write an exponential function when they just give us the 2 coordinates. So an exponential function is like y equals a times b to the x power. So what we're going to do is we're going to come up with 2 different equations using these coordinates to sub in for the x and y. So if I chose 1, 6, 1 is obviously the x, 6 is the y. So if I replace this equation with those x and y's, we have y equals a times b to the first power. Now if we clean that up, b to the first is just b, so this would really be 6 equals ab. If we did that with the other equation, we'd have y, which is 24, equals a times b to the third power. Great. So here's our 2 equations. So step 2, we're going to solve those like a system of equations. So it's going to be easier if we can get this first a or b by itself. I'm going to get a by itself. So if we get rid of this b, we'd have to divide it. So 6 divided by b is going to be equal to a. So we can take this and substitute it in the other equation for a. You done did it with the system of equations back in the day. So we'd have 24 equals, drop your marker. Our new a is actually 6 over b times b to the third. Now, if we were to rewrite this and mush it together, you know what, I'm going to scoot over here. When you multiply a whole number times a fraction, it just gets multiplied in the numerator. So this would be 6b to the third over b equals 24. Now b to the third divided by b would be b squared. So we'd have 24 equals b squared. 6b squared. all my 6's and b's look the same here. To solve this, we divide by our 6. 24 divided by 6 is 4. It's b squared. We're just looking for b, so we'll square root it, and we'll just take the principal square root on this one. B equals square root of 4 is 2. So we have b. Now to figure out a, we can substitute that into either of the equations. This one over here is probably going to be the easiest. A equals 6 divided by b, which we know b is 2. So a would be 6 over 2, which is 3. A equals 3. And now we're going to take this a and b, we're going to sub that into the original function, y equals a to the bx. We're not going to put in the y or the x. We're going to leave the variables. So let's write our final equation here. So the skeleton for it is a times b to the x power. Well, we know that b is 2, so it'd be times 2 to the x power. And the a, we came up with 3. So y equals 3 times 2 to the x power. Now, if you substitute in either one of the coordinates, it works for this one. Let's see what the coordinates are. 1, 6, and 3, 24. If we tried 1, 6, 2 to the first is 2 times 3 is 6. Great, that works. If we tried 24, 3, 24, it'd be 24 equals 3 times 2 to the x power is 3. 2 to the third is 8, and 3 times 8 gives you 24. So they both work. That's it. We're all done.